Welcome to Bard's Breathe Easy Service Training. My name is Rick Downey. I'm the trainer here at Bard Manufacturing. Today we're going to review the electronic expansion valve and recovering refrigerant in the Bard dehumidification units. The Corel EEV is used in our standard wall mount unit with hot gas reheat and in the classroom QH units with that dehumidification feature. In this video, we'll review the sequence of operation, verify how it's functioning, and how to reclaim refrigerant from a unit with this valve. Step-by-step elimination of each component using diagnostic lights and a meter to verify the operation. And last, we'll learn how to manually set superheat up for temporary operation in case you need to order a part. Let's start by reviewing safety first, and then we'll verify the EEV sequence of operation. Warning: there is an exposure risk to high-pressure refrigerant unless you follow these steps. This unit is equipped with an electronic expansion valve. In order to fully recover refrigerant or evacuate the system during repairs, we need to make sure that the valve is open. Use the service tool, and that's part number 2151-021, and you can use this to manually open the EEV. If this tool is not available, be sure and recover refrigerant from all three lines, or ports. These include suction line, liquid line, and discharge line. Failure to follow the process and the directions in this video could result in eye injuries or refrigerant burns. Remember, let's work safely. To safely open this refrigeration system on units equipped with the EEV, you must follow these instructions and use the following methods. With the power off, you can use the electronic expansion valve magnetic service tool to open the valve as described in this video and safely reclaim refrigerant from the two ports located near the compressor. With no service tool, you need to reclaim refrigerant from all three line ports, and that would be the liquid line, suction line, and discharge line. Because the valve closes at the end of a cycle to prevent migration or to protect the compressor during any alarm or failure condition, this will be trapping refrigerant in all three areas. If you need to repair a leak and the unit will run, you clearly see on the gauge refrigerant is flowing and your EEV is open. You can simply turn off the power to the unit while it's operating. Flipping the breaker off stops the current and the EEV cannot power close. Then you can recover all the refrigerant through the discharge and suction ports. You cannot drop the cooling coil. Only breaking the power while a cooling coil is in place and the valve is operating will keep the valve open. And note that all units manufactured after September 1st of 2020 have an added port to the liquid line, so there is easy access to all three ports. Units with a date code before September of 2020 fall into two service groups, and they're listed on the next slide, and the refrigeration systems must be accessed following the directions listed. Since not all techs have the EEV service tool, we added a port to the liquid line to allow reclaiming refrigerant when it isn't practical to wait for a tool to arrive. However, the electronic expansion valve magnetic service tool is always the easiest and best option. These units are broken down into two groups. First group is small cabinet heat pumps and small cabinet air conditioners and large cabinet air conditioners. Those units all have a port on the liquid line. Some ports are used for the low ambient control when that option is ordered. If the option is not ordered, they're just capped and they're available. So the low ambient control is screwed on over a Schrader valve and may be removed for reclaiming refrigerant. And always wear your proper PPE when working with refrigerant. The second group is the large cabinet heat pumps, and that would be the W42 through W60H units, and those do not have a port on the liquid line. With no EEV service tool and you can't run the equipment and verify the valve is functioning to turn the power off, the only option to safely open the system up is to add a self-piercing valve on the liquid line and recover from all 3 lines, or wait until you can acquire an EEV service tool. The EEV system consists of the valve body, stator, control board, relay, temperature sensor and transducer on the suction line. The transducer and temperature sensor provide real-time data to the control board, so real-time superheat can be calculated and applied. The output signal from the board determines the EEV position. The controller is programmed to maintain 13 degrees of superheat. There are no adjustments required or possible, ever. The superheat you measure may vary slightly, plus or minus 5 degrees, from the set point because of the location you measure and tolerances in the equipment. So if you're going to check the superheat and you get between 8 and 18, that's acceptable. The relay is used to activate the EEV control board anytime the compressor contactor closes, signaling the valve to go into operation. A refrigerant call enables the EEV. Either air conditioning, heat pump, or dehumidification activates the control. And this is a two-way valve. Even on heat pumps, there will only be one EEV. And you're checking the superheat for some reason. Not enough capacity and the unit runs continuously, or you have frosting on the evaporator. Maybe your suction pressure is at 0, or the unit is locked out on low pressure. We need to eliminate the EEV as the cause. And remember, pay careful attention to what line you're reclaiming from if you must reclaim from all 3 lines. The control has parameters built in for components and superheat for compressor protection. If the control operates outside these parameters, the EEV closes to protect the compressor. Remember, many of these same symptoms often come from other causes like low airflow and undercharged systems. Let's take a look at component location. You can see where the EEV is located in the left side of the cabinet. On the right, you can see the sight glass in the cover of the EEV control panel, and to the right of that, you can see the panel open. This is the control board, and under the control board is the relay I talked about earlier. That relay needs to be activated in order to start the EEV process. This EEV system is on all barred standard wall mount units with DHUM except the T and C series. This is the troubleshooting chart that appears in the manual. I put some arrows up here on the indicator lights. The solid green LED is on whenever there's 24 volts on the board. The flashing red LED is indicating that one of the faults has occurred and the control has closed the valve. The red constant on LED indicates operating parameters of the control have been damaged in the board and the board has to be replaced. We're going to use these lights and our meter to verify that the EEV system is operating. If the green LED is not lit, then we don't have 24 volts to the control board or it's defective. We need to measure on the orange terminal strip on that board between G and GO. If we have 24 volts present and the light is not on, we have a defective board. Remember, if the red LED is solid, the control is damaged and the board needs to be replaced. With no power on the EEV control, the next check is R to C on the DHUM board. And you can see in the lower left corner, I have a big red arrow there pointing to R, and the white and red dotted line goes from G. That's where we get our 24 volts for the board. The board is powered all the time. If we have 24 volts from G to GO and the green light is off, the board is defective. If the board is defective, we need to set up the EEV for manual operation, and we'll learn how to do that a little farther into this video. If the green light is lit, but superheat is not being maintained, or we don't think it is, we need to stop right here and check the superheat. If it's within range listed below, that's between 8 and 18 degrees, the EEV is functioning normally. Let's install some gauges. Attach your thermistor approximately 6 inches ahead of the suction line bend before the compressor so we can get a temperature measurement, and be sure you put it between 10 and 2 o'clock. Check your charge and your superheat. If the superheat is out of range, move on to the next step in the chart. If your superheat is within range, look elsewhere for the cause of the symptoms your unit has because the EEV system is functioning properly. The next step is to verify that the relay is closing. When energized, the closed contacts allow the digital input terminal to see ground and enable the controller. In the lower left corner, there is a picture with an orange terminal strip. The green light is on, indicating that we have 24 volts on the control. If we measure between G and digital input, or DI, G and DI, and the relay is closed, we will get 24 volts. If we don't get 24 volts there, then we need to check the relay and find out why it's not closing. If voltage is present and the relay is closed, then the control board is enabled and we need to continue on to the next step. If the relay is closed and there's no flashing light, the board may be the culprit, but we need to complete our checks to be sure. We need to complete the remaining checks in the manual on all components. A shorted coil or a grounded sensor could allow unrestricted current flow and damage the board. Here, the red light is flashing due to an out-of-range parameter and the valve is in protection mode. We need to check the following. The valve is seeing low superheat and the controller is taking steps to protect the system by closing the valve. Number 1, the stator coil or coil wire connection. Remove the stator coil plug from the EV control board and ohm out the coils as shown below. The resistance of the windings should be around 40 ohms plus or minus 10%. So the 4 sets that will have resistance are listed: yellow, purple, white, red, blue and purple, and green and red. If your resistance falls outside these values, replace the stator coil. So 40 plus or minus 10% is 36 to 44, where all your measurements are going to fall. And also, check all equipment to ground. Now that we know the coil is okay, let's check the valve out, see if it's stuck in a position. Remove the coil from the valve body and use the EEV magnetic tool to adjust the stem position, confirming that the valve is not stuck. Rotate the tool counterclockwise until the tool clicks like the last revolution on the gas cap of your car. The tool is designed to click when fully open, fully closed, or if it's stuck and immovable. If the valve clicks in both directions and doesn't move, the valve body will need to be replaced. The human hand doesn't make a full rotation like a drill. Therefore, you're going to need to make many partial turns. My range requires approximately 40 partial turns from open to full closed. So don't give up after 20 turns on that valve. Keep going until you get a click. As long as the valve stem moves, the valve body is good, so we can move on to the next step. Here we need to verify the thermistor sensor is operating accurately. Make a visual check for broken wire insulation, broken wires, or cracked epoxy material. To disconnect the 10K sensor from the EEV control box, remove the plug and use an ohm meter to measure the resistance between two conductors. Also check for a short, which is 0 ohms, open, infinity, or check each wire to case ground. Compare the resistance reading to a 10K table for accuracy. Secure your sensor to the suction line for an accurate comparison. You know, there's a allowed tolerance of plus or minus 10% on this read. If the sensor is out of tolerance, shorted, open, or grounded, replace with the exact part. Many volt and ohm meter units have large tips on the probes. Several electronic components have small tabs or openings that can be damaged by these probes. We recommend small sharp probes for accurate reads and damage prevention as shown at the left. We have now eliminated the coil, the valve, the temperature thermistor on the suction line, and now let's check out the transducer. To do that, we need to verify that the transducer sensor has 5 volts DC between red and black. The plug you need to check is on the top right of the EEV board, but under the plug there are 3 bare metal connectors that go from the plug into the board itself. Measure right there. Use your small probe tips on there and you're going to measure between red and black. You should have 5 volts DC. Remember to set your meter to DC if your meter doesn't automatically adjust. With 5 volts DC here and the system running, you need to check the signal between blue and black, and you're looking for a reading between 0.5 and 4.5. In the example on the screen, our gauges are connected and I have 120 psi on the low side. We multiply the gauge reading times 0.016 and we get 1.92. And as you can see in that example, I have to add 0.5 to it. Whatever my calculation, I run first, and then I add that 0.5. My voltage should be 2.42. Looking to the right of the calculation, you'll see a suction pressure transducer chart with a blue line running from left to right. That's the voltage as the pressure goes up. That's how the curve works for this transducer. You see my red line at 120, going to the right until it connects with the blue line and then straight down. If you look close, you'll see that it lands on 2.42, and this is correct. The transducer is functioning properly. If the transducer is functioning properly, you can skip the next slide. If for some reason the voltage doesn't check out, then we're going to have to check out the wiring harness. So if the voltage didn't check out, we need to confirm the integrity of the connections and the wires. Use an ohm meter and check all 3 wires in the transducer harness for resistance and to see if they're shorted to ground. Replace it if it's defective. Also, as shown in the picture, be sure the wires are inserted in the right spot on the transducer plug and EEV board. If the voltage doesn't match the expected voltage, using the calculations on the previous slide while the wires check out good, replace the transducer. If you find a wire in the wrong spot on either end of the harness, replace the harness. We just went through and checked out all the components. However, if we found a defective part during the process and have to order that part, the valve will have to be set up manually in order to get this unit back into service. Remove the coil from the valve body and use the EEV tool to adjust the stem position until closed. Rotate the tool counterclockwise until the tool clicks. From the closed position, open to approximately 50%. That is approximately 20 partial rotations in the opposite direction. Replace the evaporator door and start the unit to check superheat. Let it equalize for a few minutes and determine if you need to open or close to increase or decrease the superheat. Remember, the directional arrows for open and close are on the top of the EEV tool. Repeat as many times as needed, turning the tool 4 or 5 turns in the beginning. When you see you're getting close, drop that down to 2 or 3 turns, and finally, when you get down to 0 in there, you might only be doing 1 or 2 turns on your last trip inside the evaporator compartment. And then leave the coil off until you get the part and you're ready to put the EEV system back in service. After you replace the needed components and reinstall the coil, the valve will work automatically. It will just move to the right position. Use this same process to open the valve to 50% before opening up the refrigeration system. In summary, the easiest way to service the refrigeration system is with the use of the EEV magnetic service tool. If you need to service the refrigeration system, follow these directions to stay safe. Here we learned how to use the lights and a volt ohm meter to verify operation and rule out component failure, and that we can set the superheat manually with the EEV magnetic service tool for temporary use. Remember that the DHUM supplemental manual, if you would like these instructions in writing, manual 7960-828 is available from bardhvac.com. Don't forget about Bard Technical Service Hotline. We have a technical service department down there, and they're waiting to help you out. If you have any questions, give them a call at 419-636-0439, and that's 8 to 5 Eastern Standard Time. If you have any training questions or you need some more information from me, you can contact me at rick.downey, D-O-W-N-I-E, at bardhvac.com. I'd like to thank you for viewing this video, and thank you for choosing Bard.